So I design tools, and this is what some of them look like. So these are tools for people making software, making electronics, making music, animation, working with mathematical equations. These areas where you're making something that does stuff. So you're making something that has complex behavior. And my focus has always been on how can the creator see that behavior? How can they see what the thing they're building is actually doing? And what are powerful ways of seeing so they can understand what that thing is doing? Now, these have generally been software-based tools, and what software-based means today is that these tools are trapped inside a tiny rectangle that sits on your desk. And do your work, you sit at your desk and you stare at this tiny little rectangle, and that frustrates me. Because if you think about a lot of the traditional forms of craftsmanship, they take place in a spatial environment, a room that's designed for that purpose, where the worker is surrounded by tools, where they can walk around, use their body, use their hands, think spatially. The room itself kind of becomes a macro tool they're embedded inside. It's like an extension of their body. So I've been taken with this idea of designing tools in the form of rooms, in the form of spatial environments. And so I was thinking about this and thinking about spaces for making things, and that led to thinking a little bit about makerspaces. So makerspaces are these communal workshops that are becoming popular nowadays, where people come together to create in a shared social environment, and they have access to powerful, high-end equipment that they wouldn't be able to afford as individuals. And I really like these two aspects of makerspaces. I like creating in a shared environment, I like access to powerful tools, and I like the philosophical motivations behind this maker movement, that instead of consuming mass-produced products, people should make their own things. And so what I wanted to share with you today was this idea for how to take these maker goals to the next level. So what I'd like to do is I'd like to design a new kind of space that enables and empowers creators in ways that today's makerspaces don't really support. So if you go into a makerspace today, you'll probably see a laser cutter, and you might see a 3D printer, and welding equipment, and plastic forming equipment, and lathes, and mills, and drills, and sawing, and sewing, and soldering, and these are all wonderful tools, but these are all construction tools. These are all tools for taking material and sticking it together, right? And those are precisely the tools you need if you're making something like furniture, or if you're making simple mechanical contraptions. But more and more, we're seeing people making a different kind of project. More and more, people are making things like robots that roll around, robots that fly around, robots you can talk to, that tend your garden, clothing that lights up, clothing that responds to how you move or responds to people around you, musical instruments, bike displays, machines that scan books, 3D printers, self-balancing vehicles. So all of these kinds of projects have a high amount of internal complexity, often with embedded software, and that give rise to complex behavior. They're often taking an input from the outside world and then responding to that world in complex ways. And when you're making a project of this sort, the primary challenge is not putting the pieces together. The primary challenge is understanding what the thing is doing and why it's doing that and how you can get it to do what you actually want it to do. So, for example, if you're making a little robot and that robot's supposed to move towards the light, you put down your robot and you turn on the light and it does not move towards the light. What do? Well, you have to get in there. You have to get inside that robot's head and see what it's seeing and see what it's thinking and come to understand why it's behaving the way it's behaving. And the construction tools aren't going to help you here. What you need here are seeing tools, and we don't really have many of those. And the few seeing tools that we have tend to be very primitive, tiny rectangles that sit on your desk. On the other hand, there are a few people out there that take seeing really seriously. So, for example, here's how NASA does it. So if you're launching a space shuttle, you need to understand everything that's going on in this very complex system. So they have sensors everywhere, and they design this room, this spatial environment, where you can sit there and you can see and understand and control every last little bit of that system. This is Fermilab, the control room at Fermilab, the particle accelerator in Illinois. This is the California power grid, and this is a Canadian power grid. This is a waste treatment facility. This is a TV station. And this is the Large Hadron Collider at CERN, where they recently found the Higgs boson. These people know that if you're trying to design a system of this complexity that you have to understand in real time, you have to build a room. You have to build a room where you can go in there and understand everything that's going on. And that's the kind of thinking that I'd like to bring to mainstream engineering and making. What I'd like to do is take this idea of a makerspace and transition it to a seeing space. Create an environment that's entirely around seeing and understanding what the project that you're building is actually doing. Shifting the focus from putting the pieces together to deep understanding. So it's almost like a giant microscope that you're embedded inside that's focused on what you're building. Now, when I think about a seeing space like this, I think about seeing on 3 different levels, 3 progressively more powerful ways of seeing. The first step, before you can see anything, is you need something to see. So you need a way of collecting data and a way of displaying that data. So you make this little robot. The way many of these projects are done today is with a kind of last century stinginess, where you put on just the bare minimum sensors and the bare minimum processing power, the bare minimum communication capabilities. And so as a result, most of the information you'd actually want to see is never collected or accessible in the first place. I've seen so many projects fail at some point because some wire came loose. And the conventional thinking is, oh, that's the fault of the builder for not attaching the wire strongly enough. The way I see it is it's the fault of the wire for being too dumb to know whether it's attached, right? We now live in a world where sensors are cheap, processing is cheap. We need to start working with smarter materials that collect a lot of data about what's going on out there, collect a lot of data about what's happening inside the box, and then can transmit that data up into the room. And then we design the room in such a way that it reflects all that information back to the maker. And so you can put information on walls, you can project onto the workbench. There's many ways of displaying information. The point is you have to get that stuff out of the box and into the environment where anything that you would want to know is just kind of a glance away. And then once you have the means of collecting data and the means of displaying data, now you can start to think about how should we display that data? What are powerful ways of representing this kind of information? And one of the most powerful ways is time. So we tend to think moment to moment, see things moment to moment, and it's not until you step back from those moments and look across a range of time at once that you can start to see patterns, that you can start to think about systemic causes. So if you have your little robot and you let it go, and it did something weird back there, just like a few seconds ago, it did something. That moment went past, but what did it do back there, right? You want to be able to grab it and run it back. And why not? Why not work in a space where there's video cameras everywhere, everything's being recorded, everything's being marked and tracked. You just look up and bring it up, grab time, run it back. See what happened, right? Take time and put it into the maker's hands. And then think about ways of seeing across time. So look at the path that the robot followed, look at all the data that was collected during that run, be able to browse through it, see what was going on with the external sensors, see what was happening inside the box, take measurements on that data, compare what happened this time to what happened last time, understand the effects that your changes are having. And all of this data is being collected and stored because today digital storage is free. And so your entire history of what you've done with this project automatically becomes a kind of notebook where you can just browse through everything you've done, you can see all the video, you can see all the data, you can see any notes you took, and you can search. So if you notice that a sensor reading is kind of high, you wonder, like, was it ever that high in the past? You just search for that. You find sessions in the past that meet that condition. You just go in there and you figure out what was going on. And the most critical thing here is that all this just is taken for granted, right? It's just built into the material, it's built into the room. The maker doesn't have to think about it. They don't need to do anything special. They just show up and start building stuff. And all these tools are just at their disposal. So once you're able to see across time, now there's an even more powerful way of seeing, which is seeing across different design alternatives. So should we make the robot behave like this or behave like that? Well, you do it both ways, and you see which one works. If you have a robot that's supposed to go towards the light, you might need to give it a setting to say like how sensitive it should be to the light. And the way that's done today is often with a kind of knob where you try it out in the setting. Oh, that didn't work too well, so we try it out in this setting. Maybe that works better. You're kind of poking around. It's very ad hoc, very unsystematic. And I'm talking about an environment where instead of choosing one particular setting, you can just go across an entire range and you just say go. And the room and the material work together to do a test run at that setting, try it out, collect that data, and then automatically try the next one, and try the next one, go through that entire range, try them all out, collect all the data, and then you can just look at it and see what actually happened in all those cases. You have all the data, you can take measurements, you can reduce the data, you can figure out which is the actual best possibility. And not just which one is the best, but why it's the best, because you can see all the context. So designing this kind of seeing space, where the entire focus is being able to see and understand what this complex thing you're building is actually doing, shifting the emphasis from putting material together to seeing and understanding in powerful ways. And some of what I'm talking about is probably going to be expensive, but that's the entire point of a makerspace, is shared access to expensive tools. That's the reason to think of this as a shared space. And some of this might be a bit of an engineering challenge to build, but 3D printers and space shuttles are also engineering challenges. And we as a culture have decided those are important things that we want to have. And so really kind of the main thing that's needed here is the recognition of how important seeing is, and the will to do something about it. I want to close by explaining why I feel this is so important. We talk a lot about making nowadays, but the way I see it is making exists on a spectrum. There's these different ways of thinking that we draw on in different combinations at different times. So on the left, I've put tinkering, which is where you're trying stuff out, you're trying to find something that works. You don't really understand the underlying principles by which it works. You don't really have a clear mental model for why this works and that doesn't, but you find something that works and you go with it. And this is a very important way of thinking, especially for beginners. This is where we all have to start. But it's also important that on the spectrum, it kind of fades over into engineering, which is where you do understand the underlying principles. You do have a clear model of why this thing works. It's often a mathematical model. You can write a few equations that describes how the thing behaves. So you have this theoretical knowledge that's guiding your design decisions, and that's incredibly powerful. But what do you do when you don't have that theoretical knowledge? So this theoretical knowledge often comes from something like a textbook. What about when you're working in a domain where the textbooks haven't been written yet? And that's when we start moving over to the right side, towards a more scientific way of thinking, where you're discovering and codifying those underlying principles, where you're generating that theory that engineering relies on. And this is incredibly powerful because this is how we explore and map out new territory. This is how you build new kinds of things and understand them deeply enough to build them reliably and robustly. So where all this fits in with tools is if you just give somebody construction tools and teach them how to use it, they can work in this range. If you then also give somebody conceptual tools, if you give them theory, now they can work across this range. But if you want somebody to span that entire space, to be able to draw on all those ways of thinking, they need to be able to see what they're doing. They need powerful seeing tools so they can see what's going on and understand it really deeply. And so that's the real reason why I'm interested in building a space like this, is because I think people need to work in a space that moves them away from the kinds of non-scientific thinking that you do when you can't see what you're doing. Moves them away from blindly following recipes, from superstitions and rules of thumb, and moves them towards deeply understanding what they're doing, inventing new things, discovering new things, contributing back to the global pool of human knowledge. Thank you.